Okay, so this is the program for duffing oscillator. As you know, it's second order coupled nonlinear force oscillation. So this second order second order differential equation is converted to two first order coupled nonlinear equations by putting x dot equals to y. So first x dot equal to y will define the first function fx as y, and when you substitute fx x dot equals to y in the other equations, you will get y dot equals to minus dy. So d here is omega naught square minus d here is alpha minus a into x, so a is omega naught square minus b into x cube, so b is beta here, plus f is strength of external harmonic force, and omega here is w is here is the omega, the frequency of external harmonic force. So basically we have inputs a, which is omega naught square, b, which is beta cube, d, which is alpha, omega, f, and k1. So the ratio of k and k1 will give you the interval which will be used in the algorithm for solving the differential equation, and k is the number of times you will iterate the algorithm to get the solution of these two equations. Okay. So we have the initial condition x equals to 0, y equals to 0.7 and t equals to 0.0. Then so this is the algorithm. So start from j equals to 1, it will go up to the number of iterations defined by u in the increment of 1. So when j equals to 1, x equals to x, y equals to y, and t equals to t. So that means it will take the initial value which you have defined earlier, and then for given t and given x and y for the initial conditions, it will calculate 4 values of x and that for y, and then it will take the weightage value of x and y, and then it will be iterated again. So in the next iteration, whatever x and y value at t is calculated, that will be the input, and then it will generate our next x and y for the given t, and hence when you keep on iterating, you will generate x and y as a function of t. So you can plot either x and y, which will give you the phase portrait, or x is a function of t or y is a function of t, and you can see all the if the effect of the external parameter on the solution. Okay. So let us solve it. So it will run this. So it's anyway just a warning, so it will not affect our results. So this is the executive file, you run it. So you need omega naught square, which is minus 1.0, this is your first input. Then beta is 1, I guess, yeah. Then alpha, which is 0.5, then omega, which is 1.0, and then f. So initially I will take 0, then k is the number of iterations, let's say it's 10,000. Let's say the file is cs2.dat and plot. So when you plot it, the graph is like this. So you have to zoom in this portion. Yeah, start from 0. So this is the behavior. So it oscillates back and forth, and finally it will approach to the equilibrium points. So it's a damped oscillations, you know. Okay. Okay. So just